Hi, this is Subhash Kopana. This project is for Human Factors in AI course, Ethical and User-Centric Design for Predictive Maintenance. Let me start with task analysis. The problem currently working on is in a manufacturing setup, unplanned equipment downtime leads to significant production delays and losses. That will increase the operational cost, which may actually lead to a customer dissatisfaction for missing deliveries. So our key task is to enable maintenance teams to take timely and informed actions by predicting equipment failures before they actually occur. Uh, Before implementing ML, currently, the equipment is monitored, inspected manually, and the production teams wait for equipment breakdowns or some alarms, and they call the technicians, so react to the failures. The technicians diagnose the issues manually and log the events after fact. After implementing our ML-based solution, system will automatically predict the potential failures. The dashboard flags the machines at risk. Technicians receive the alerts with the risk level, confidence score, and suggested action. Options will be there to make comments, give feedback, and override the predictions. So the key insights of the task analysis. It simplifies the detection because ML automatically detects based on the historical data, simplifies the diagnosis, and optimizes the scheduling. It allows for planned maintenance during non-production hours and improves the actionability. Users are informed in advance with the failure risk levels so that they can inspect and provide solid feedback loops. UX design. So users primarily interact with the system with the help of a centralized dashboard, which displays all the machines, their health, the risk scores, and any active alerts. Also, all the maintenance staff, which are key stakeholders, get the mobile notification for critical alerts. So the key considerations of AAUX are user inputs and feedback loops is the first one. Input is primarily a sensor data, which is passive. But on top, users confirm or deny the predictions, provide the repair outcomes and machine inspections, update machine status after the maintenance. The primary feedback loop here is technician provides feedback after inspections, which helps the retain the model. The second one is transparency on the model. It provides a short model explanation like high vibration and elevated temperature triggered this alert. And secondly, a link to more detailed logs when it is needed. So third one is uncertainty, how we communicate. So visual cues. Use the clear risk levels, low, medium, high, with corresponding color coding and probability scores. Displays the percentage of confidence scores, like 75% likelihood of failure. And also provides contextual explanations, explicitly states that these predictions are probabilistic. Emphasis on human judgment remains vital for final decision. Privacy concerns are machine sensor data that can reveal operational details and machine details, possibly sensitive in a competitive manufacture sectors. Also, maintenance logs may include technician details and shift patterns. It could indirectly reveal individuals or team performance metrics. On top, we may have to follow the privacy laws of India, which is DPDP 2023. And if the data is exported globally or saved in a global cloud, we may be subjected to GDPR and CCPA. On top, industrial IoT security guidelines will also apply for device data handling. So our approach to mitigate and to comply with the laws, we primarily need to anonymize the technician identifiers, encrypt the data, maintain audit logs and data access, implement RBAC to the dashboards, avoid storing any PII which is not necessary for the operations, and implement regular security audits and define clear data retention policies. Ethical considerations. Potential sources of bias are historical data bias, basically from incomplete failure data, model overdrifting to certain machine types or environments, operational context bias, which is lack of contextual understanding. Example, machine may operate differently in a different load profiles. How do we meet ethical AI principles? Fairness. We train the model on diverse machine types and environmental conditions. Monitor for disparities. We validate performance across all equipment categories, conditions, shifts, etc., and continuously evaluate a model performance. The second one is accountability. Maintain logs of all model predictions and their outcomes. Auditability. Implement comprehensive logging of all predictions, human interventions, and actual outcomes to allow for us to go through post hoc analysis and debugging of errors. Also define escalation protocols when model predictions are disputed and changed. The third one is transparency. Clear explanation for each alert or prediction, like failure importance, reasons for the code, etc. Allow users to inspect decisions and override suggestions where required. Publish the model documentation with versioning and monitor reports and performance metrics regularly. That is all I have. Thank you so much for the review. Have a great day.